Have you ever stopped to think about what makes your phone screen so incredibly tough, but the charcoal in your grill just crumbles? Or why a lemon has that sharp, sour taste while soap feels so slippery? Well, it all comes down to the fundamental building blocks of our world, so let's dive in and explore the two great families of matter and the chemical opposites that literally shape everything around us.
Right, let's kick things off with this simple question. What is it about a coin that makes it shiny and strong, while a piece of charcoal is dull and just falls apart in your hand? I mean, they seem like total opposites, right? And you know what? In a way, they absolutely are. They belong to two completely different families of matter. So on one side, you've got your metals, the shiny, strong, and shapeable stuff. And on the other side, you have nonmetals, which are often dull, brittle, and sometimes they're not even solid at all. These are the two great families of matter. And really getting a handle on their differences is the key to unlocking how our world actually works.
Okay, so first up, we're going to explore these two families. We'll take a close look at what makes a metal, and what makes a nonmetal, well, its complete opposite.
Just picture a simple copper pot. It's strong and tough, right? So it can handle the heat on a stove. It's shiny. It's also malleable, which just means you can hammer it into a shape. And it's ductile, so you could stretch it out into a thin wire. If you tap it, it makes that nice ringing sound. We call that sonorous. And maybe most importantly, it's an amazing conductor of heat, which is why it cooks your food so evenly. That right there is a classic metal for you. Now let's flip that on its head and look at nonmetals. Let's go back to that piece of charcoal, which is mostly carbon. It's dull, it shatters easily, it's brittle, and it is a terrible conductor of heat. In fact, it's an insulator. The properties of nonmetals are pretty much the polar opposite of metals. It's like they're playing by a completely different rulebook.
So, pure metals are incredibly useful, for sure. But what if we could make them even better? What if we could mix and match them to engineer something brand new, something even stronger? Well, that's exactly where alloys come in.
So what exactly is an alloy? It's simply a mixture of elements, usually metals, that are melted together to create a totally new material. By combining them in just the right way, we can create materials that are way better than the individual parts. It's almost like we're hacking nature to build better things.
So here's the big question. Why are alloys so much stronger? Well, think about it like this. In a pure metal, the atoms are all the same size, and they're stacked in these perfect, neat layers. They can slide past each other pretty easily, which is why a lot of pure metals are kind of soft. But now imagine you toss in some atoms of a different size. All of a sudden, those perfect layers are totally disrupted. They get in the way, locking the whole structure in place and making it much, much harder to bend or break.
And alloys, they have completely shaped human history. Bronze, which is a mix of copper and tin, gave us new tools and weapons. It literally defined an entire age. Steel, that's just iron mixed with a tiny bit of the non-metal carbon, built our modern cities and all our infrastructure. And amazing alloys like duralumin are so light yet so strong that they're the reason we can fly an airplane.
Okay, so far we've been talking about physical stuff, like strength and shininess, but that's only half the story when it comes to matter. There's a whole other side, its chemical properties. So now we're going to switch gears and explore two chemical opposites that are just as important, acids and alkalis.
Believe it or not, you run into acids and alkalis every single day. Acids, like the citric acid in a lemon, have that unmistakable sour taste. Alkalis, on the other hand, like the soap you use to wash your hands, feel slippery or soapy to the touch. They are true chemical opposites, each with its own unique personality.
But here's where it gets really, really cool. What do you think happens when you mix an acid and an alkali together? They don't just sit there, they react. They go through a process called neutralization, where they literally cancel each other out, creating a new substance that is neither an acid nor an alkali.
Okay, but how do we know how acidic or alkaline something is? We definitely can't go around tasting everything. That would be an incredibly dangerous idea. So we need some kind of scorecard, a way to measure their chemical strength. And that's exactly what the pH scale is for.
The dead center of this scale is the number 7. This is perfect neutrality. It's not acidic, it's not alkaline, it's just balanced. The best example of this you can think of is pure water. It's the ultimate balance point in the chemical world.
The pH scale runs from 0 all the way to 14. Anything below that middle point of 7 is acidic, and the lower the number, like lemon juice, the stronger the acid. Anything above 7 is alkaline, and the higher the number, like bleach, the stronger the alkali. It's a really simple but incredibly powerful tool for understanding the invisible chemical forces all around us. So, we've explored the fundamental properties of matter.
from the physical toughness of metals to the chemical punch of acids. But the real magic happens when we put all this knowledge to work. Let's look at a super clear, practical example of this.
Okay, imagine you've got this messy mixture of iron filings and yellow sulfur powder. They're totally jumbled together. How on earth would you separate them? It's actually really simple. You use a property that's unique to the metal, magnetism. You just bring a magnet close, and it will attract all the iron, pulling it right out of the mixture and leaving the non-magnetic sulfur behind. It's such an elegant way to show how understanding these basic properties helps us solve real-world problems.
So, from the alloys that let us soar through the sky to the chemistry that keeps our own bodies in balance, these properties of matter are the fundamental rules of our reality. By understanding these basics, we can not only explain the world around us, but we can start to shape it too. The possibilities are truly endless. The only real question is, what will you build with them?